Okay. So is it audible? Is it audible? Okay, great. Okay, so we learned about the common catenary equation. So both in the Cartesian format and in the intrinsic format, right? So we are going to solve some of the problems based on that understanding. Right? So the intrinsic form of the equation, and this is S is equal to C tan psi. So this is the intrinsic form of the equation, and the Cartesian form of the equation. This is y is equal to C cos hx by C. So this is the Cartesian form of the common catenary equation. Now this equation is for the common catenary, which is like this, and this is x-axis and this is y-axis, and then this is usually treated as C, and this is the sag, and the sag is usually represented with B. So the highest point is nothing but C plus B. And then if you consider a random point P, so this is treated as A, and this is C, and this is B. So AB is S. So this is the S. So this is called perimeter, or actually just keep it as it is like this, yes. Now to solve some of the problems based on this understanding, so you have to identify one phenomena, that is as ds tending to 0. So this is ds. So this is like a curve. Now as ds tending to 0, this curve can be treated as a straight line, right? As ds tending to 0, so I call this as PQR, and PR will be a PQ will be a straight line. PQ will be a straight line. Now from there actually, so this angle is psi, or actually I will enlarge this. So this is P, and this is Q, and this is R, and this angle will be psi. So this psi is nothing but, if you draw a tangent, so this is the angle psi that is making with respect to the x-axis. Now this angle is psi, and this is dx, and this is dy, and this is ds, and ds tending to 0. So from here actually one important conclusion what we can make out is, this is being the right angle triangle. So here actually cos psi is equal to dx by ds, and sin psi is equal to dy by ds, and we have the intrinsic equation, that is S is equal to C tan psi, right? So whatever I have written on the board now, so this is the complete understanding about the common catenary. Now whatever we are going to solve is based on only this understanding. So if you are clear with this understanding, then you will be able to solve all the problems related to this common catenary. You please tell me if you have any questions in this understanding. No? Okay, great. Now actually, so between these two relations, right, so there are different variables actually that we have used. So S is nothing but the length from A to any point on the common catenary, and psi is the angle made with the tangent that is drawn with respect to the x-axis. So this is the angle psi, and y is nothing but the ordinate, or actually at any instant actually the height is nothing but the y coordinate. So this coordinate is nothing but x comma y. So if this coordinate is x comma y, so the relation between the x comma y for common catenary is y is equal to C cos hx by C. Now using these four variables, that is S, psi, x and y. Now actually, so these values actually are interrelated. So with these two formats, right? So this can be interrelated. Now actually, we will try to establish the relations between different variables in this particular case. So let us consider one particular case. So relation between X and S. Can you try to establish the relation between X and S? So this X and this S, based on the knowledge whatever we have acquired based on this understanding. Can you try to establish the relation between X and S for a common catenary? Anybody got the idea? How we can relate S and X? Try to eliminate psi and Y. So we have got only these two equations, right? So this is equation number 1 and this is equation number 2. From these two equations, so try to eliminate psi and Y and establish the relation between X and S. Anybody got any idea how we can do this? Okay, so let me solve this. See this. So S is equal to C tan psi. C tan psi is nothing but C into dy by dx. Because from this triangle, dy by dx is nothing but tan psi. So which is nothing but the slope at the point what we have considered here. So this is the slope at this particular point is given by dy by dx is equal to tan psi. So this is equation number 1. And the second relation actually y is equal to c cos hx by c. So if you try to find out dy by dx for the second relation also, so y is equal to c cos hx by c, dy by dx equal to c into derivative of cos hx is sin hx, and then by c will be there. So sin hx by c, right? So from here actually dy by dx can be expressed as s by c, and here actually dy by dx can be expressed as sin hx by c. So this is equation number 3 and this is equation number 4. So from 3 and 4, s by c is equal to sin hx by c, or s is equal to c sin hx by c. So this is the relation between s and x. Got it? I hope you understood. This is straightforward and simple. Any questions, you can let me know. Any questions? Okay, so you can note down this and then try to establish the relation between, so here actually x and s, right? Now try to establish the relation between s and y. Anybody got the idea how we can establish the relation between y and s? So this is just manipulation of these two equations, nothing more than that. Anybody got it? Okay, so let me solve this. So we have got one relation from the previous example, that is S is equal to C sin Hx by C. And then we have already have the relation Y is equal to C cos Hx by C. Now, if you square it and add it, S square plus Y square is equal to C square times of sin H square x by C plus cos H square x by C. So, sin H square plus cos H square will be 1. So, S square plus Y square is equal to C square. Now, if you notice, this is the relation between S and Y. Got it? Yeah, that's correct. Now try to establish the relation between phi and psi. Between y and psi. Can you try to establish this? Anybody got the relation between these two? Between y and psi. So y square is equal to c square into 1 minus tan psi by 2. Is that correct? Okay, anyway, so let me find out. See this. So to establish the relation between these two, so let us consider dy by ds, dy by d psi. So dy by d psi, which will establish the relation between these two. Now actually, to simplify this, we will be using the methodology by dividing by ds and multiplying with ds. So why we are doing this way is dy by ds actually from this relation actually we know. So dy by ds is nothing but sin psi. This is dy by ds. And we know the relation between s and psi also. S is equal to c tan psi. So if you make it this way, you will be able to easily establish the relation between these two. So keeping that in mind, so dy by ds, d psi is equal to dy by ds is nothing but sin psi, and then ds by d psi. So the derivative of this with respect to psi, that is c into derivative of tan psi is secant square psi. So secant square psi. So this is dy is equal to c into, so sin psi divided by cos square psi is nothing but secant psi into tan psi. secant psi into tan psi into d psi. Now if you integrate on either sides, so y is equal to c times of secant psi plus a, some constant. So integral of secant into tan is nothing but secant. So c secant psi plus a. Now this a value actually we need to be finding out, because actually this is the arbitrary constant which we have got by integration. So to find out the relation, so y equal to c at psi equal to 0. That is at this particular location, that is at x is equal to 0. So this y value is c, and the tangent at this location will be exactly horizontal, which will make an angle of 0. So secant 0 is 1, and then y is equal to c. So both the c will cancel out, and then a equal to 0 as y equal to c at psi equal to 0. So from this relation we have got y is equal to c secant psi. So this is the relation between these two. Got it? So one more method is actually we have got another relation, right? So c square is equal to s square plus y square, and then y is, so s is equal to c tan psi plus y square. So this is equal to c square. So y square is equal to c square into 1 minus tan square. So earlier relation what we have got, right? So is it y square plus s square is equal to c square? I think this is on the other side. Can somebody confirm this? Yeah, so this is on the other side. So this will be plus. So then actually y square is equal to c square into secant square psi. So again actually from this relation you will arrive at the same relation. So these are the two methods which you can adopt to find out the relation between these two. Got it? Now can you try to establish the relation between x and psi? So earlier it was y and psi. Now actually x to psi. Can you try to find out the relation between these two? Anybody got the relation between x and psi? Adopt the same procedure what we have adopted now. So let us consider dx by d psi, so that you can establish the relation between x and psi. So again do the same thing, dx by ds into ds by d psi. So this is dx by d psi value. So dx by ds is nothing but this value, which is cos psi, and ds by d psi. So derivative of s with respect to psi. So this is c into secant square psi. So if you do the integration, so dx is equal to c into cos psi into secant square psi is nothing but secant psi. So into d psi. If you integrate on either sides, this is x is equal to c times of log of secant psi plus tan psi plus some arbitrary constant b. These arbitrary constants you can find out by taking any particular point. So usually we take the origin, or actually this location, which will make y is equal to c and x is equal to 0 and psi is equal to 0. So at x is equal to 0, psi is also 0. If psi is 0, then secant psi is 1 and tan psi is 0, and log of secant psi is nothing but 1. Log 1 is 0. So c is equal to, so 0 is equal to c into log 1 plus 0 plus b. It implies b equal to 0. So we have got the relation x is equal to log secant psi plus tan psi. So this is the relation between x and psi. Can I try to establish the relation between tension and ordinate? You note down this, I am going to erase it. Done. But try to establish the relation between tension and ordinate. Ordinate is nothing but y. So the value of y and the tension relation. Or actually, if I randomly give you any y value, then you should be able to tell the tension at that particular point. Tension and ordinate. So let us consider this particular point. Let us say this is the tension at this tangent point. Then the horizontal component of the tension will be T cos psi, and which is equal to the horizontal component which is acting in the counter direction. So that is, this is T naught. So this T naught, actually we call this as the tension at the bottommost point, which is acting in the opposite direction to balance this tension which is acting tangentially at this location. So the horizontal component will be balanced by this. So this is T cos psi is equal to T naught, or T is equal to T naught into secant psi. So cos psi, actually if you bring it to the other side, this is going to be T naught into secant psi, and we know the relation T naught is equal to W into C, so which was initially discussed. So that is, you have identified the parameter value C, whose multiplication with the weight per unit length is equal to the horizontal component of the tension. So this was the initial assumption what we have made. Now if you replace here T is equal to W into C into secant psi. And then we have recently established one more relation. Y is equal to C secant psi. So this is the new relation actually what we have established. Now if you replace it here, then T is going to be W into Y. So this is one of the very important relation. So at any instant, the tension on the string is nothing but the weight per unit length getting multiplied by this height. Got it? And then actually, so there is one more thing is, find the radius of curvature at any point of the catenary. At any point of the catenary. Now actually you need to understand what is the radius of curvature. So radius of curvature is a generic term, right? So what is the radius of curvature of a circle? What is the radius of curvature of a circle? Can somebody tell me what is the radius of curvature of a circle? Okay, so let me explain. The radius of curvature of a circle is nothing but the radius of the circle. So the generic term of this radius curvature, we mean, suppose in a graph, right? So there are only two different kinds of graphs actually you can draw, or actually two different types of curves actually you can draw. One is straight line. So this is a straight line. And other is a curve. So this is a curve. Only these two types of structures actually will be drawing on a 2D graph. Now here, the straight line, right? So straight line we mean there is no curvature. Curve we mean there is a curvature. So this is the only difference between two different graphs here. So straight line means which is having a constant slope. So this is the constant slope. And this is having continuously a variable slope. So this variable slope, so the way we construct this particular curve is nothing but, so if you divide this part into infinite small parts, so each part is having a curve of radius certain value. So this is R1 and this is of R2 and this is of R3. So like this actually there are different radius values which you can make use to draw these curves at infinite small. Got it? So each elemental part of this particular curve is constructed by a radius, but this radius will be continuously changing at every point of this particular curve. So if you wanted to find out the radius of curvature, I mean at every point the radius value will be different, and this is dependent on the xy location of this particular curve. So everywhere there will be an associated radius, and that radius value we call as the radius of curvature of the curve. So for a circle, so it is going to be the constant curvature. So at any point, right, if you try to construct this elemental part of the curve, so it's nothing but it will having a fixed value of the radius, so which you can use. So this is the fixed value of the radius. So everywhere actually the radius is same. So that is why for a circle the radius of curvature is constant. But for any curve, the radius of curvature will be definitely a variable. Got it? So for finding out the radius of curvature, there are two different methods that we are going to adapt it. Now actually when we derive the differential equation of a circle, or actually any circle, actually we have derived one differential equation which is nothing but rho is equal to 1 plus dy by dx whole square whole power 3 by 2 divided by d square y by dx square. So this is the differential equation of the family of the circles which can fit onto the xy coordinate system, which is nothing but having a fixed radius, but the center is located at different locations on the xy plane. So that kind of curve, if you form the differential equation, you are going to arrive at this particular value. So this value is nothing but the radius of curvature for any curve, and this value for circle, it is a constant. So this value for a different curve, actually you are going to get different values. Got it? So this is what is the radius of curvature, 1 plus dy by dx whole square whole power 3 by 2 divided by d square y by dx square. Now, if this psi value, which is nothing but if the curve is making an angle of psi at any instant, if you draw the tangent, then ds by d psi, so that is the curve length from this particular location is s, then ds by ds is also called as the radius of curvature, which will give the same value. Got it? Now here actually, so we have got the relation between s and psi. So that is s is equal to c tan psi, and then ds by d psi is nothing but c into secant square psi. So this is the radius of curvature. Got it? That means this portion of the curve can be constructed by a value of the radius whose value is equal to c times of secant square psi, where psi is the angle made with respect to the x-axis. Got it? So this is the radius of curvature. I hope you got a fair clarity on this. So based on this understanding, now let us solve. So these formulas, actually you have to be aware to solve problems on this common catenary. So whatever the relations we have derived, so these values actually we have to be remembering. And also actually, so there are cases actually where in the examination, right, so all the relations were asked to derive. Okay. So note down one problem, small problem. If the normal at any point P, if the normal at any point P of a catenary meets the directrix at Q. Directrix at Q. Show that PQ equal to rho. Show that PQ is equal to rho. So can you try to find out this? This is a straightforward relation. Anybody got it? See this in this one, right? So this is the point, and there actually if you draw a normal like this, and then this is meeting the directrix at Q, then actually what he asked was, so he asked us to find out this length is equal to the radius of curvature of the curve at that particular location. Got it? So here actually this angle is psi. So if this angle is psi, and if you try to draw a straight line from the point to the directrix, this angle will be definitely 90 degrees because this is the perpendicular. Now, if this angle is 90 degrees, then this angle is pi by 2 minus psi, and then being this as the normal, so this will have 90 degrees with the tangent. Obviously, this angle will be psi, right? So this angle is going to be psi, and then so you want the relation between PQ and the radius of curvature, right? So PQ value, if you want to find out, or actually if you want to find out the height, which is nothing but the height, so this is P and this is I call as R. So PR equal to, from the diagram, PR is equal to PQ times of cos psi, or PQ is equal to PR secant psi. So PQ what we want, and PR is nothing but, this height is nothing but the ordinate value. So this is y times of secant psi. So PQ is equal to y into secant psi. Also, we know that y is equal to c secant psi. So this was the relation which we have established earlier. Now, from this actually, PQ you can write as c times of secant psi into secant psi is nothing but secant square psi. And earlier actually we proved that S from S is equal to c tan psi. It implies ds by d psi. This is what we call as the radius of curvature, which is represented by a letter called rho, and this value is equal to c secant square psi. So from 1 and 2 we have got the relation. From 1 and 2 we have got the relation, that is PQ is equal to rho is equal to c secant square psi. Got it? Any questions on this? No. Note down one more. If T be the tension at any point, if T be the tension at any point, P of a catenary and T naught that at the lowest point, and T naught that at the lowest point A, prove that T square minus T naught square is equal to W square. This is capital W. W being the weight of the arc AP of the catenary. W being the weight of the arc AP of the catenary. Got it? So can you try to prove this relation? Then great. So here actually, so T cos psi is equal to, is the horizontal component. So that is T naught, and T sin psi is equal to Ws, which is nothing but the weight of the arc AP, which is acting at the center of gravity, like this. So this is Ws, which we call as capital W now. So because actually he stated that Ws is equal to the weight of the arc. So this is, I call this as capital W. Now here if I square it and add it on either sides, this is T square into sin square psi plus cos square psi is equal to T naught square plus W square. So this is T square minus T naught square is equal to W square. Got it? Note down one more. A rope of length 2L. A rope of length 2L. 2L feet is suspended. Is suspended between 2 points at the same level. Between 2 points at the same level. And the lowest point of the rope is, and the lowest point of the rope is B feet below the point of suspension. B feet below the point of suspension. Show that the horizontal component of the tension is W times of L square minus B square divided by 2B. W being the weight of the rope per foot of the length. W being the weight of the rope per foot of the length. Can you try to solve this? So here actually, so the length was given in feet, and from here to here actually that is 2L length. That means this part of the length is L and this part of the length is L. So 2L length actually it was given, and then from here to here, so between the point at the same level, and the lowest point of the rope is B feet below the point of suspension. So this is the point of suspension and these two are at the same level. Now if you draw a line like this from here to here, this is the value actually from here to the lowest point. This was given as B, which is nothing but the sag, right? So sag was given as B. Show that the horizontal component of the tension. So the horizontal component of the tension is nothing but T cos psi R, which is equal to again T naught. So he asked us to find out the T naught value, which is going to be equal to W times of L square minus B square by 2B. So So now try to find out this relation. Anybody got the idea how to solve this? Anybody got it? So we have to make use of the relations what we have derived in the previous session. So see this. Here actually we have got the relation. What he asked us to find out is T naught value in terms of the sag. So sag is nothing but the height. So the relation that we can establish is the sag, right? So sag is related to y value, right? So this is the y value from here to here. So if you notice, the highest point is nothing but this value, which is equal to this value. So this height, if I consider it, this value can be divided as till this point C and this point is B. So y is equal to C plus B is the highest point. This is the highest point. Why we are finding out the highest point is from this relation we need to find out W times of C. This C value actually you should be establishing in terms of B. For that purpose actually we have identified a relation which will involve C and B, right? So we have got the relation that is y square is equal to C square plus S square. So this is one relation actually what we have established now. So this is y square is nothing but C plus B whole square is equal to C square plus S square. So S is nothing but from here to here length. So that was given as L, right? So L square, since S is equal to L. So from this relation, if you simplify this, C square plus 2BC plus B square is equal to C square plus L square, and the C square will cancel out, and then C is equal to L square minus B square divided by 2B. So this is the relation. So once you got this relation, you substitute here. So T naught equal to W times of L square minus B square divided by 2B. So this is the horizontal component of the tension, and which is again equal to T cos psi, which is nothing but the horizontal component at any point. Clear? Got it? Any questions on this? Any questions on this? Okay. So this is about the common catenary. I hope you got a fair clarity on this topic. So this is one of the simple topic which you cannot afford to leave any part of it, right? So and this is very important also. So sometimes actually in UPSC straightforward the calculation of sag or span or the arc length were asked based on the parameters what were given in this particular case, right? So I'm going to give some of the problems as an assignment today. So you try to solve those problems. In case if you don't know any particular problem, you tell me, I'm going to explain in the next class, or else I will be starting a new topic in the next class. Got it? Any questions or anything which you don't understand in this part? Okay. Yeah, so that's great. So I'm going to give an assignment. You try to solve that assignment. Yeah. Thank you. Good night.